Okay, in this video we're going to look at graphing linear equations of the form y equals mx plus b. And we've created scattergrams from tables of values and written several equations for the exact or approximate linear models. In each of those equations we had a starting value and a rate of change. The form of our equations were output equals the starting value plus the rate of change times the input. And just to give you a quick reminder of one of the examples we did, was suppose that the profit of a company was represented by P, T years since, say 2010, and we had a table of values where every year the profit went up by $2 million. So to find the profit, P, we started with, I think it was $3 million in the year 2010. So we started with $3 million, and then we added the rate of change, which was $2 million, T years. So that was the equation that represented the profit after T years. The starting value was $3 million, and then we added $2 million every year. Okay, so that was the first basic example that we did. And note that the starting value was the y-intercept, or the output intercept. So in that example, the output intercept, or the p-value, okay, the p-intercept was $3 million. Now what we're going to do is we're going to graph equations that are using generic xy coordinates rather than in the context of a word problem, okay, like profit in years since 2010. Okay, so if we just want to, given the equation y equals 2x, make a table of values and sketch the graph, well, now we don't have any context for what the x and y actually represent. Like, we don't know x is the number of years since 2010. We don't know that y represents profit or anything like that. So we just want to graph these on the grid that we're given. Okay, so one way to look at it is think about numbers you can substitute in for the input x, and then what answers would you get for y. So if you chose a number like, say, like x equals 10, then that would be y equals 2 times 10, which is 20. Well, that would be the point 10, okay, which is way out here to the right, and then 20 would be way above where our grid is. So we don't want to plug in 10 because that's going to be off the grid. Okay, so what we'll do is to start these off, we'll generally choose around x values of 0. So maybe x is -3, -2, -1, 0, 1, 2, 3. Okay, so if we use those values, then we should get values that show up on the grid fairly nicely. And you can see if you do 2 times -3, you get -6. So if we choose to do a table of values, if x is -3, then y will be 2 times -3, okay, which is -6. And then if x is -2, you'd have 2 times -2, which is -4. And then if x is -1, 2 times -1 would be -2. I'm not going to write down 2 times the x value each time. If x is 0, 2 times 0 will give you 0. If x is 1, 2 times 1 is 2. If x is 2, you'd get 4. And then if x is 3, 2 times 3 is 6. Okay, so if we wanted to plot all those points, -3, -6, that would be x is -3, so 1, 2, 3 to the left, and then down 6. There'll be a point right here. And then -2, -4 will be this point. -1, -2 is right here. 0, 0, 1, 2, and so on. Okay, so we can see that if we were to draw that line through those points, okay, we get that nice line. Okay, and we'll label it as y equals 2x. Okay, and that would be the first one. Okay, so that's graphing using a table of values. Now, one thing I'll point out on the calculator, if you have the TI-30 calculator, okay, so if you have this one, okay, this is going to be a very useful thing for you. So with anytime you're given a y equals equation, okay, what we can do is go to table, and notice how it says y equals. Now, you may or may not have anything in there. Yeah, I just press clear to clear out whatever's in there. So if we want to graph y equals 2x, we'd have y equals 2, and then the x variable key, let me slide up here. The x variable key is right here. Okay, so we'll press 2 times x. Okay, and then we'll press enter. And then what'll pop up is your table settings. Okay, and it says start at -1. Now let me just scroll down with all these settings, starting at -1 and step equals 1 with auto, and just show you what that is. What's going to happen is your table is going to start at -1. The step means it's going to go up by 1 each time. So so it'll have -1, 0, 1, 2, 3, and so on. If I click OK, see it starts at when x is -1, it gives us a y value of -2. And notice that's a value that we have in our table. Now when you do this on your own, okay, what you want to look at is you want to find all the values that will fit on your grid nicely. Now our grid goes from -10 to 10 for the x values and the y values. So you want to fit values in there in our table that'll fit on the grid. So notice when we get to -6 for x, we're going to get -12, which will be off the grid. So we could actually go all the way to -5 in our table. Now I just chose -3 because there's several values there for us to see the pattern of what's happening to graph the line. But -5, -10, okay, that would be the value way down here, which is on the grid. And then -4, -8, that'd be this point. Okay, and you can see that's on the same pattern or same line as what we just graphed. Okay, now if I go back to table, okay, and we have y equals 2x. If I press table again, oops, I'm sorry, press enter first. And now it's starting at -6. That's what I scrolled to. But you can start wherever you want. Okay, if I said let's start at say -30, and then step of 1, the next values in the table will be -29, -28, and so on. If I go to the table, and I suppose I start at -30, I could use a scale of 0.5 if I want. What that'll do, it'll put -30 as the first value in the table, and then go up by 0.5s. So -29.5, -29. You can use your arrow key to scroll whichever way you want, up or down, and that's one way to create a table of values. But again, the table that I want to see are values that'll fit in nicely to our grid that you can actually plot. Okay, if I go back to the table, and if I go to Ask X, okay, so if I highlight that, and then OK, oops, it had values in there from before, sorry. But you can enter whatever you want in. So I can enter like -5, -4, I can enter 7 in. Okay, so you can basically create your own table with the Ask X feature. Okay, most of the time you'll probably just use the starting at maybe -3 or -4. Okay, and then the step of 1, and then auto will actually fill in the table for you. Okay, you don't have to put your own values in. Okay, and then again, scrolling up or down, you can go either direction. Okay, so that's using the TI-30 calculator. If you have the graphing calculator, I'll go through this very quickly. Okay, so in your calculator, you want to go to y equals. If there's an equation already in there, just press clear, and that'll clear out what's in there. And then you want to enter 2x. So we have 2 times x. Here the x variable key is the xt theta n button. Okay, so, oops. Sorry, I just pressed the wrong button by accident. Okay, xt theta n button. Okay, so y equals 2x. Okay, and then if I press graph, it'll actually graph the equation for me, which is something that your TI-30 calculator won't do. Okay, and then what I can do, I can make a table of values in 2 different ways. If I press trace, It just defaults, in my case, to 0, 0. That's 1 point on the graph. But after you press trace, you can press whatever numbers you want. -3. So if x equals -3, press enter. It takes you to -6. So there's 1 point on the graph. And actually shows you where it is. And then you could do -2. That'll take you to -4. And that shows you where it is on the grid. Okay, if you put in 0, that'll take you right to 0, 0. Okay, and so on. That's one way to find a table of values. That's kind of like the ask feature on the TI-30 that I just showed you. Okay, now, another way to get your table is, see above graph how it says table in blue? If I do second graph, it'll take me to a table of values. Okay, now I have values that are higher in there from a different problem that I did. Okay, but again, if you scroll up or down, okay, then you can get the values that'll fit in the grid there. Okay, now notice how above window it says TBL set. So if I do second window, this is the same idea as on the TI-30 calculator. The table start, if I put, say, -6 in there, my table is going to start at -6. The triangle table, that really means the change in the table. Okay, that was your step in the TI-30 calculator. So the change in the table is 1, which just means it's going to go up by 1s. And then just if you leave those as auto, independent and dependent, okay, leave them as auto. Okay, and then go back to your table by doing second graph. Now notice the table starts at -6 and goes up by 1s. Okay, if I go to second table setup, suppose I started at 0 and going up by 1s. Now second graph, I'm going to start at 0 and go up by 1s. Okay, so that's how you can use the TI-84 graphing calculator to get your graph and table of values. Okay, now you want to actually plot these points on the grid though. Okay, so there is the equation, or the graph, of y equals 2x. Okay, and then we want to do in part B, y equals 2x plus 3. So for the sake of time, you would just do a similar thing, okay, where you make a table of values for x and y. And if you want to go from, say, -3 to 3 again, okay, that'll work fairly nicely. Okay, and I'll just show you the answer key because now you can put them in your calculator again. Again, if you want to use the TI-30, okay, very quickly, go to table. Now we have y equals 2x plus 3. Okay, press enter. And then again, with your table of values, okay, you can set that up however you want to get your table, like I showed you before. And then just plot points, like -3, -3. And then -2, -1, and so on. Okay, -1, 1, 0, 3, 1, 5, 2, 7, 3, 9. Okay. Now really what we're doing there, what your calculator is doing for you, I don't want to gloss over this. Your calculator is actually evaluating when x are these numbers here. Okay, when x is, say, -2. If you do 2 times -2, that's -4, plus 3 gives you -1. If x is, say, +3, 2 times 3 is 6, plus 3 gives you 9. Okay, so your calculator is not doing magic, it's doing math. Okay, it's just doing that arithmetic for you. Okay, and then you plot those points on the grid. And then I'll put part C up here also at the same time for y equals 2x minus 4. And when you're all done, your grid should look like, or your graphs should look like this. Excuse me. Okay, and here the black one is y equals 2x. And the red one was 2x plus 3, or y equals 2x plus 3. And then y equals 2x minus 4 is the blue one. Okay, so that's how you graph equations using a table of values. Okay, what you might notice with these graphs, they're all linear, okay, because a line passes through each of the points that you plotted for each of the equations. Okay, the y-intercept occurs when x equals 0. Okay, so on the y-axis, the y-intercept is always when x equals 0. So on the blue graph, okay, the y equals 2x minus 4. The y-intercept is at 0, negative 4. On y equals 2x, okay, the y-intercept was at 0, 0. And then 0, 3 was the y-intercept for a y equals 2x plus 3. Okay, and here, notice that the lines are parallel. Remember, parallel lines are lines that do not intersect, okay, like railroad tracks. Okay, they have the same slant or slope, okay, or rate of change. Okay, so notice on each of these, to get from one point to the next, if you go up 2 boxes to the right one, you end up on that same line. No matter which line you're on, if you start at one point, go up 2 to the right one, okay, you end up on that same line no matter what. So they have the same slant or slope. Okay, on the next page, we're looking at the same directions, except now we're going to put a negative in front of the 2x and see what that does to the graph. Okay, so you're going to make a table of values just like you did before. Okay, so from negative 3 to 3. And again, that's something you can do. If you need to pause the video, go ahead. But I'm going to show you the answers here for the graph. Okay, it should look something like this. Okay, I'll explain these numbers, the -2s and the +1s. I'll explain those in a minute. Okay, but here we notice that now instead of an increasing line, we have a decreasing line, meaning as you trace to the right, the y values get smaller. Okay, so the line is decreasing. Okay, the slant of the lines are still the same. Okay, notice here though that if you start at one point and go to the next point, you're going down 2 to the right one. On the other graph, we're going up 2 to the right one. But now we're going down 2 to the right one to stay on the same graph or the same line. Okay, and then I'll slide this up to get the table for part C. And if you need to pause that, okay, pause the video, go ahead. Okay, but I'm going to move on. Okay, so the basic idea is when we're looking at what's happening as far as the pattern goes on each of these, for y equals negative 2x, okay, that's the blue line right here. Okay, when we look at that, when we plug in those values for x, we get these y values, plot them, and we have a line. If we look at the pattern of what's happening, notice that when the y value goes from 6 to 4, we have to subtract 2. So in order to get from 6 to 4, you subtract 2. To get from negative 3 to negative 2 for the x value, you have to add 1. So to get from an x value of negative 3 to negative 2, you have to add 1. To get from a y value of 6 to 4, so from 6 to 4, you have to subtract 2. So from 6 down to 4, you subtract 2. Now what those numbers are telling us what the change is with each of the variables, y and x. So when you look at negative 2 change in y, that means you're going down 2. When you have a positive 1 change in x, you're going to the right 1. And that is the pattern that keeps you on that same graph. Down 2, so y changes by negative 2, so you subtract 2 from y, add 1 to the x. And that's how you stay on that same pattern. Notice each of these equations has y equals negative 2x in them. So that has to do with, once you know a point on your graph, if you have that same pattern, down 2 to the right 1, it doesn't matter which graph you're on, down 2 to the right 1, you're going to stay on that line. On the other previous equations and graphs, we had a positive 2x, which meant